To access the Open Data Registry Power data, you first navigate to the Power homepage. Scroll down to the AWS Open Data Registry page, click the AWS ODR link, and it will bring you to the Catalog Registry page. This Catalog Registry page shows you the different S3 links for the full data archive for the Power project. So the first link is the Analysis Ready Data Store, which includes the ZAR files that we'll be accessing in this demonstration. And then the bottom link is our database and CDF files if you want to download an archivable file format for a specific time period. So we're going to go into the Browse bucket for the Analysis Ready Data Store. So you can see here, once this website loads, it has all the different ZAR files structured here, as well as some processing information. We are specifically going to look at the daily local solar time radiation data, which is right here. If you go to here, you can see that the parameter structure is listed as a ZAR file. It includes the spatial index and the metadata information to read this entire data store. So you want to collect the website itself, as well as the parameter file, or the ZAR file itself. So once you have this URL, you can copy it and bring it into your code editor. Once you open your code editor, you paste the URL that was created, which is the public website access to the ZAR file. This can be the direct link like here, or you can use an S3 direct file connection as well. You type in the parameter that you want as a list, all sky. Type in the date range that you want, 2022 January 1st to December 31st. You type in the location that you want, 7.088 by negative 76.37. So now the inputs are entered. What the script here is doing is using fspec to create a readable file object. Then that data store is then used inside the open ZAR file function for X-ray. We use consolidate equal true, which loads in the metadata itself prior to actually downloading any data values. To be able to do a selection from that metadata, we do times, which is a start and end date that we entered before, with the frequency of 1 day. So we say we want to get the parameters, then we want to select the times that we've made that time range from above, the latitude and longitude, and we want to get the nearest grouping of those. And then to load the data, because it's working with metadata operations, you have to do the load function. So if we run it, you'll have an X-ray data frame print out. You can also do the same Python code inside of a Jupyter notebook. So if we click our demo Jupyter notebook here, we already have it pre-populated with the URL and the parameter we want. We can just change this to 2022 for the year. And we can type in our location again. And the same steps apply inside of a Jupyter notebook. So if we run this, you can see that the metadata loads very quickly. You can see all the data parameters that are available. Where the next step here, we've subsetted to the data parameters we want, but you notice we don't have data values in the array structure. This step here is actually loading the data. And the load speeds are dependent on your internet performance. And you can see now that there are data values. If you would like more information on how to access data from the AWS Open Data Registry, go to Docs and click on Tutorials, click on Service Data Requests, and then click on AWS. and then there's more code and information on how to access. Thank you very much.